Welcome, guys and gals, back to the den, and this is part 2 on the ChirpEE. That's the 12 volt little power supply AC. That is 3 watt. Where I left off, I had the capacitors in, I were testing them, they were bad. So I got them pulled. Obviously that would be really boring, so I pulled them and put in all new ones. Here's the list of ones that I had, and I tested. I wanted to test the ESR just to make sure the ones I was putting in, because they were used, are up to specs. So here we are. Now we're up for the big test. I'm gonna put some juice to these and see what happens. Got the dim bulb set up right here, and gonna run with it. Hopefully there'll be no explosions or nothing crazy like that. I gotta warn you guys, this is potentially dangerous and there is high voltages involved, so please don't mess around with high voltages unless you really know what you're doing, and always be careful and protect yourself. I protect myself with the dim bulb. Obviously, I could also use the isolation transformer. I got that here too, but I got the dim bulb here and clips to it and everything, so that's what I'm going to run with. That's what I go with. So we'll hook it up, see if we get some voltages out of this thing. Now again, this is putting out AC, this one. Now the second board here, again, that was the capacitor I showed you that was blown. From this board, this was the power supply for the LED board over here. So that'll be second, but this will be first. So I'll get it hooked up and see what happens. Gonna run with it. Make sure these don't touch. And DC, I want AC. Hope you guys can read that from up there. Maybe I'll bring you down in so you can see it a little better. Womp womp. There. Alright. Dim bulb. I think I'm going to put some tubing over that while I got it here. I don't like how them are so close. Scares me. I'm a little bit scared. Yes, too long. Just a little extra precaution. I didn't flip on the dim bulb yet. That'll be here in a second. Nice. There's that guy. Just with everything bouncing and moving around, I'm going to get these. Actually, I'm going to save them. These I'm going to get out of here. These are the bad capacitors that were tested. And I'll put them there. I always save my extra parts. Just, I don't know, because I'm odd. But, let's hook it up. This could be exciting because the way that capacitor, I looked at it, and it doesn't make sense. Because it's going to have a positive charge on the upward swing of the AC going to the negative of the capacitor. It's the way it is. I don't know. I did not make the board. I didn't create it. I don't know if someone modified it at one time or what, but it could be interesting because, as we know, capacitors do not like to have positive on the negative. They react rather violently. So, wondering if I should, I need to take a little precaution here. Yeah. Woohoo! Alright, I got the lid to put over it and protect shown. And if I have a mass chaos, I can put it in this and lock it down. So, just in case, let's give it some fire. And it's doing nothing, as expected. .6 volts AC. Boy, that doesn't make any sense. You can tell how much I trusted that capacitor being charged in the way I freaking was deflecting it. I do not understand this at all. It must be a, you know what it's doing? I'll bet you it's doing a, basically like pulse width modulation is what it's doing. Not quite pulse width, it's going to be changing, I'm guessing frequency. So let me go. Yeah, that's it. That's what it is. That's why it's not reading. It's violently changing. So yeah, pretty much 1.1K hertz is what that's running at, and that would make sense. The thing was a little beeper or something is what it ran, and it just go beep 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 beep. I don't understand it at all. I guess it used to sit in a Christmas tree or something, and it would be triggered if someone walked by. Odd, very odd, but hey, it seems to be working. Now, with the way that it's going is because it's AC coming out and it's changing so much. This being, I guess this isn't a true RMS then. So I wonder if, smells something funky. Got some heat going on. Shut it off. As you can see, the capacitor finally charged out there. I'm going to discharge that capacitor. Boy, that thing is getting warm. And I wonder what's getting hot. You can smell it though. Oh yeah, that resistor right here. Green, so 5, blue, 6, and 56K looks like. No, 5K6. 5 green, blue, 6, and red is 2. 5K6. So 5600K. Wonder if that's because it needs a might need an output otherwise, or some type of resistance built up on the output, otherwise it holds all its energy in and it's not good. I do want to check it with a true RMS and see if that does make a difference though. That's kind of interesting. Let me change this. I'll get the clamps on this. Or should I test out? Where are the... Let's see. Where are the ones that I used to use for? Here, they should be hanging. Here goes to the ends, and the ends would go to that. So this... Boy, this is well prepared, well thought out here, I'll tell you. So I'm guessing with that not being a true RMS meter, that's why I was getting 0.6, what is it, 0.68 something volts. We'll hook up the true RMS meter. This is a 2000 count, my clamp meter here. I'll get it in frame here in a second. I gotta find something for the ends. I should have just flopped over onto these. My plugins. Go with the big monsters? Yeah, I gotta go with the big monster ones. That's all I got. Yeah, I forgot about that. That's bad preparation if you ask me. I like to think that I prepare at least a little bit to get these videos, and not being prepared, I feel like a dumbass doing it. So anyone who watches this video gets to see me call myself a big dumb flabby ass. Alright, true RMS meter is hooked up. Let's try voltage AC. We'll go kablam with the on. It's doing about the same thing. It's kind of bouncing. Yeah, it must be the way the voltage is changing then so fast, very quickly actually. As you've seen at 1.1 kilohertz, that's fast. So the meter can't pick it up. I have to use the oscilloscope or something, which I could get my little demo oscilloscope out, but it's weird. That thing has some weird. Maybe we will. We'll see how much time we got. Let me bounce onto number 2. So this, we know at least it's doing its output, which it should, and it should be kind of low voltage coming out of it. It shouldn't be 0.6 volts. It should be higher. It should be 12 volts like that. But again, I'm reading it. It's supposedly a true RMS meter, but I don't know how accurate it is either. I mean, it's reading 0.1 volts sitting there, so whatever. I don't know. I know when you start adding in big frequencies that they get thrown off. That's where the oscilloscope comes in. So again, here's the LED hooked up, the lights set up. Changed the capacitor, and I found an inductor that I believe would be similar to the one that was on it. And I'll get this guy hooked up. There's my outs. That marked black. Black was gray on that. And that is off. Didn't really say. I want to see what's positive and negative. Okay, this one is negative. There's positive. Am I on it? Right on it. Wow. Hope you guys can see this as it's happening. Get this back to voltage. Now this should be DC coming out. This one does. Yep, it's got the rectifier on the bottom. So that's actually what I'm used to. I'm not used to really working with like an AC one like that. It was kind of odd, I'd have to say. Well, let's give it some juice. 249. She is fixed. Ha ha ha! Cool. 250. 249 volts. DC. That's cool. Oh, I'm glad that's fixed. No heat, no smell. Let me see what the frequency is on that. interested to see if it's changing at all on with the other meter. Get this hung up. Pop this guy on. Still could have a charge on it with that big capacitor. So I'll try to be a little bit careful. Hooking this up. Oh, lost it. Lost my positive. Oh, let me zap that on quick. Warm that up. That's off. I'm gonna discharge that capacitor so I don't get waxed. And again, anyone interested, that's I just got a 68 ohm, 5%. This is a what is it, 3 watt? I believe, yeah, 3 watt resistor, just in line with these two pins. Just basically putting a resistor across the capacitor, drowns it out. I need my spool. These things always come off. It never surprises me. They always do that. It's like they're not put in well or something. Make sure it's in good. There's a whole, just a mess of solder on the back. Oh yeah, the other one looks like hell too. And you really don't want to do like I did and put the solder to your iron and then put it on, but you know what? I've fought with this thing for so long, these little tiny parts, and I have a hell of a time. So I do what works for me, but you're really not supposed to, but it sits on your iron and it's supposed to burn the flux off before it's used, but that's what I do. I've always had good luck with it, so what do you want from me? Not perfect. Back to Hertz. Interested to see what this thing's running at. This was my positive, right? Yep. I gotta shut this off. And I want to tin it before it cools down. Got the little tiny tip on there. Right. Try the frequency. And nothing. How is it nothing? Oh, here we go. Yeah, I'm not sure what the deal is here. Again, 250. Well, either way, we know it's working, so that is bonus. Let's get it hooked up. Positive. Red is my positive. Positive's got to go here. It's the best way. Let me drain off the capacitor so nobody gets blapped. I'm actually excited that they both work though. That's awesome. This board here it's rough, rugged. I mean, if you look at the Look at the solder, and I went over all the soldering on it because it was rugged. It was looking rough, so I went through everything, but I'm very surprised that it works. Even the transformers look like they've had better days. Much better days. Alright. I solder them. They're gonna fall off. Let me just clip them quick. Where's my clips? Old trusty red and white. Red is positive. Now this was the circuit board for this LED, so it shouldn't have any problems. My last video, part 1 of the ChirpEE there, you could see I I had a 58 volt power supply to run that, and even that wouldn't pop it on. I had a blip. What was that? How could I have a flicker? Ruh-roh. Yeah, bad connection or what? How the heck did I just have it blip like that? Let's see what the voltage is. If I just hold it on there, it's 250. 248, so that shouldn't be a problem. So why would it be a problem up here? Must have some bad LEDs. I hope I got that on so you guys could see that. Barely. When I popped it on, it did flicker for a second and then it went up. Not sure what the deal is. Wonder if I got a bad connection or what. I'm going to pull this off of here and test it. I want to get this shut down. I want to drain this capacitor off. Looks like I don't have to. It looks like they do have a resistor in line with it. Something drawing it off because I haven't had any pops yet when I go to drain it. A lot of times you'll see it spark right in there if you got a fully charged capacitor. Now I gotta find out why this isn't working. Why would that not work? Now I gotta think. I hate thinking. Not a thinking day. I could try testing them out. Is that gonna work? Yeah, that'll work good. Now we'll do diode tests. See what we get. Try my fancy new testing unit here. My Tweezies. They were a couple dollars. I wish I could remember exactly how much they were, but I tell you, just the little bit I've had them, they are freaking handy. These are really handy to have. Instead of trying to get in there on all these little things, just lap this across it. Reading OL, so flip it around. Might be OL in both ways. I'm in diode mode. You can see it's working. I wonder if it blew them out. How would it blow them out when it's hooked the same way that it was? Positive's coming in there, so let's go this way. Not getting a reading at all. Wonder if it did blow them out. Sorry about that if I had to freaking... This thing, the DMM, way out of line where you guys couldn't see it. I'm getting nothing on these. This is very strange. Let me pull this off and see what's going on here so I'm not milking the dog. Oh, you guys are sitting there bored. Give me a second. Alright, that's something very strange, but I guess that I blew out my LED bulbs somehow. I don't understand. All I can figure is my inductor somehow was putting out, I don't know, too high of a pulse or something, and it blew the bulbs because they're wide open. I checked all of them. I wanted to show you exactly what's going on here. So I put that voltage. Make sure you guys can see that good. And there's just nothing. Either way you put it, no matter any of them, there's nothing. Just wide open. And just to show you that the thing is working, here's a LED strip out of a Dynax, D-Y-N-A-X TV. And I'll go through and test these to show you. Boom. Come on. There we go. That one back here's got, that's why I got marking on it. It's tough. It did work though when I tested. I had to put the pins on. But see, you can obviously see that it works. So, it beats me, but somehow it blew all them out. But, on the other hand, I did find a beeper. So, I'm going to try a beeper. I got a big beeper, buzzer, I guess we'll call this. Here, I'll get that hopped in quick and try to buzzer out. See if we can get some buzzering. I'm just curious to see. That's short. Open. Not sure if that's going to work then. Don't know if buzzers make a connection inside or not, to be honest with you. I'll have to strip this one out and find out. Come on. Man, the tiny wires make it tough. Alright, we'll get this hooked up. We'll see if we can get some buzz on. I do want to test that. Yeah, even this buzzer's open, so I guess that's how they are till they get voltage through them, then they vibrate. So that's pretty much how they work, is they get a pulse through them and it makes them buzz. And the higher the hertz of the pulse, the higher kilohertz, the higher the pulse. Except unless basically young kids, the top of their hearing is 20 kilohertz. And then, like us, older, I guess, people, folk, it's right around 10. I did was messing around the other day, and the highest I could hear on my signal generator there was 12. It could have been the speaker that I was putting it through, or it could have been the speaker putting it through. Might not have been able to handle higher, or I couldn't hear it. Not sure. But that's the highest I know I could hear, so it sounds about right. Okay, again, this is the AC hookup. Our DC board, I'll get that moved out of here since we know the board works, so I'll get that marked and put away and saved, because it is nice to have. And this is pretty much going to be junk, I hate to say. They're all open. It blows my mind that blew all of them, but it's not like they even went that bright. They just kind of flashed quick. Let's see here. See if we get a buzz. Nope. Not even a blip. So I don't know. That bulb could, or that buzzer could be shot. I have no idea. Yeah, these buzzers. That's a dead short, so I don't want to hit that one. Yeah, there's nothing going on. Huh, that's strange. Very strange. I wonder if I put it through a speaker. Got a crappy speaker somewhere here. See if we can hear something through a speaker. Where's that? Here's a little cheap speaker. Should hear a pulse of something. Just a... Come on, get off. Hey! That's the noise that it made. That's the ChirpEE! It's the ChirpEE! I don't understand. That's basically it. That's the noise that it made. Very similar. Wow, that is freaking strange. Don't ask me what is going on here, because I'm not even sure anymore. I don't think I have a clue. So I guess it was run through a speaker then. Try flipping it around and see what it does.